February 3, 1943. Ladd Army Airfield, Fairbanks, Alaska, 5:45 hours. The C-47 transport never left the ground. Captain Hayes completed his pre-flight checklist in darkness, the cockpit temperature reading -42 degrees Fahrenheit. Outside, ground crew had spent 3 hours preparing the aircraft, scraping ice from control surfaces, checking hydraulic lines, loading cargo bound for Nome. The twin Pratt & Whitney engines had been covered with insulated blankets overnight, a standard cold weather procedure that was supposed to keep the oil from freezing solid. It hadn't worked. Hayes engaged the starter on the port engine. The propeller turned once, twice, then seized. The oil in the crankcase had thickened to the consistency of molasses, creating friction that the starter motor couldn't overcome. Metal ground against metal. Something inside the engine cracked, a sound every pilot dreaded, and the propeller stopped completely. Hayes shut down immediately, but the damage was done. The connecting rod had fractured, punching through the cylinder wall. Engine oil leaked onto the frozen tarmac, steaming in the Arctic air. The C-47 was grounded. The cargo, medical supplies, cold weather gear, ammunition for the Nome garrison, would sit in Fairbanks while maintenance crews tore apart an engine that had been destroyed by temperature, not enemy fire. And this was the third engine failure in 2 weeks. Ladd Army Airfield, Base Operations. Colonel Matthijs stood in the operations office, staring at the growing stack of maintenance reports. 15 aircraft grounded due to cold start engine failures, 6 engines completely destroyed, 2 emergency landings when engines seized mid-flight, and winter was only halfway finished. The Alaskan Air Command was responsible for the most critical supply route of the war, the Alaska-Siberia Air Ferry route, delivering American aircraft to the Soviet Union under the Lend-Lease program. Planes flew from the continental United States to Fairbanks, then across the Bering Strait to Soviet territory. The route kept the Eastern Front supplied with bombers and fighters when no other delivery method was possible. But the cold was killing them. Current operational capacity, Matthijs asked his operations officer. 62%, sir, down from 85% last month. And the forecast? Another cold snap, temperatures dropping to -50 by week's end. Matthijs walked to the window overlooking the flight line. 20 aircraft sat in various states of maintenance, their engines wrapped in blankets and tarps, ground crews working in conditions that would freeze exposed skin in minutes. Good men doing everything by the manual, following every cold weather procedure the Army Air Forces had written. And it wasn't enough. The problem was simple physics. Aircraft engines required oil to lubricate moving parts. At temperatures below -30, standard aviation oil became too viscous to flow properly. Engineers had developed winter-weight oils with lower viscosity, but even those thickened dangerously in extreme cold. And once the oil solidified, attempting to start the engine meant metal scraping against metal with catastrophic results. The manual solution was engine blankets and periodic ground runs to keep the engines warm. But blankets only delayed freezing, and ground runs consumed fuel while exposing the engines to thermal stress from repeated heating and cooling cycles. They needed a better solution, and they needed it before the entire airlift operation collapsed. Base Mess Hall, 6:30 hours. Margaret Hayes, no relation to Captain Hayes, pushed the serving cart through the mess hall, delivering breakfast to pilots and ground crews rotating through the 24-hour operation. She was 43 years old, widow of a Pan Am mechanic who died in a plane crash 2 years before the war. She'd taken the job at Ladd Field because it paid better than anything in Seattle, and because staying busy was easier than remembering. The work was simple: cook meals, serve food, clean kitchens. Nothing glamorous, nothing that required expertise. Just honest labor in a place where honest labor kept an air base running. She'd heard the pilots talking about the engine failures. heard the frustration in their voices, the way they described watching engines seize, the helplessness of sitting in a cockpit while metal destroyed itself because the temperature was wrong. Her husband had talked the same way about mechanical problems, the anger at losing aircraft not to enemy action, but to physics and engineering limitations. Margaret returned to the kitchen, where industrial steam kettles were already heating water for coffee and oatmeal. The kettles were surplus Navy equipment, designed to produce massive quantities of hot water using coal-fired boilers. They ran continuously, keeping the kitchen warm and humid even when the outside temperature could kill. She opened the valve on the nearest kettle, releasing a blast of steam that fogged the air. The steam carried heat, enough heat to keep the entire kitchen above 60 degrees despite walls that were barely insulated. The moisture condensed on metal surfaces, forming droplets that dripped from overhead pipes. Margaret wiped condensation from a serving counter and paused. Steam, heat transfer through water vapor. The way it maintained temperature across distance, flowing through pipes, carrying thermal energy to wherever it was needed. She thought about the aircraft engines sitting on the flight line, freezing solid overnight because blankets couldn't maintain temperature. She thought about the way her husband had described engine oil, how it needed to stay warm, how it needed to flow, how starting a cold engine was like asking a machine to run dry. What if you didn't let it get cold in the first place? Margaret walked to the storage room where spare kitchen equipment was kept. She found what she was looking for, 20 feet of copper tubing, the kind used for water lines in restaurant equipment. Thin-walled, flexible, designed to handle steam pressure. She carried it back to the kitchen and held it near the steam kettle's outlet valve. The copper warmed immediately, conducting heat efficiently. Steam flowing through tubing would carry thermal energy with almost no loss. If you could route that tubing through an engine compartment, around the oil pan, through the cylinders. It was absurd. A kitchen worker thinking she could solve an engineering problem that had grounded the Alaska Air Command. She had no credentials, no technical training, just the vague mechanical knowledge she'd absorbed from 20 years of marriage to a man who'd lived inside airplane engines. But the principle was sound. Steam carried heat, engines needed heat, the connection was obvious. Margaret looked at the copper tubing in her hands. Then she looked at the flight line through the kitchen window, where ground crews were covering another engine with blankets that wouldn't work. She could stay in her lane, keep cooking, let the engineers figure it out. Or she could test an idea that might be completely stupid or might save lives. Tomorrow morning, before the breakfast shift started, she would need access to an aircraft, and she would need someone willing to risk their career on a widow's theory about teapot steam and frozen engines. The question was whether anyone would listen. February 4, 1943, Ladd Army Airfield, 500 hours. Margaret arrived at the maintenance hangar before dawn, carrying a canvas bag containing copper tubing, pipe fittings, and a small hand pump she'd borrowed from the kitchen. The hangar was lit but quiet. Night shift had ended, day shift hadn't started. One aircraft sat inside, a C-47 with its cowling removed, exposing the port engine that Captain Hayes had destroyed yesterday. Staff Sergeant Kowalski was underneath the engine, marking parts for replacement. 51 years old, career Army, he'd been maintaining aircraft since biplanes were standard issue. He heard footsteps and rolled out from under the engine, expecting his assistant. Instead, he found the mess hall cook. "Ma'am, this is a restricted area." Margaret set down her bag. "I know, I need to show you something." "The kitchen's on the other side of the base." "This isn't about the kitchen." She pulled out the copper tubing. "It's about why that engine seized." Kowalski stood slowly, wiping grease from his hands. "You're going to explain engine failure to me." "No, I'm going to explain heat transfer." Margaret's voice was steady. "My husband was a mechanic, Pan Am commercial routes. He died in '39, but I spent 20 years watching him solve problems. This is one he would have recognized. Kowalski crossed his arms. I'm listening. The oil froze because the engine lost heat overnight. Blankets slow the loss but don't prevent it. You need active heating, something that maintains temperature instead of just insulating. We know that. We run engines periodically to keep them warm, which wastes fuel and cycles the metal through thermal stress. What if you kept the engine warm without running it? How? Margaret held up the copper tubing. Steam circulated through tubing wrapped around the engine block and oil pan. The steam carries heat continuously, keeping the oil fluid, keeping the metal above freezing. When you're ready to start, the engine's already warm. Kowalski stared at her, then at the tubing, then back at her. You want to heat an aircraft engine with kitchen equipment. I want to heat it with thermodynamics. The equipment is just plumbing. And where does the steam come from? Base has coal-fired boilers for heating. They produce excess steam capacity. We tap into that, run lines to the flight line, connect to aircraft overnight. She gestured at the C-47. Disconnect before flight, same as you'd remove engine blankets. Kowalski was quiet for a long moment. Around them, the hangar was cold enough that their breath fogged. The damaged engine sat exposed, a testament to what happened when metal and cold collided. You're serious, he said finally. Completely. Ma'am, I've been fixing airplanes for 26 years. I've seen every improvised solution mechanics can dream up. Most of them don't work. The ones that do work usually violate a dozen regulations. And how many engines have you lost to cold starts this month? Kowalski's jaw tightened. 15. How many more before they ground the entire operation? He didn't answer. Margaret opened her bag and pulled out a technical drawing, rough but clear, showing copper tubing routed around an engine block with connection points marked. I'm not asking you to install this on operational aircraft. I'm asking you to test it. One engine, overnight, controlled conditions. If it doesn't work, you've lost nothing. If it does, I've implemented an unauthorized modification based on advice from a civilian cook with no engineering credentials. Kowalski picked up the drawing, studying it. Colonel Matthijs would have my stripes. Or he'd have a solution to the problem that's killing his mission. Kowalski looked at the destroyed engine, then at the drawing, then at Margaret. Why are you doing this? Because my husband died when an engine failed, and because I know what it sounds like when pilots talk about watching their aircraft destroy themselves. Margaret's voice stayed level. I can't bring him back, but maybe I can stop other wives from getting the same telegram. Kowalski folded the drawing and put it in his pocket. Tomorrow night, we'll test it on the damaged C-47. Engine's already ruined, so we can't make it worse. But if this fails, if it causes any additional damage or safety hazard, we stop immediately. Agreed. And ma'am, if this works, you understand the Army's going to take credit, right? You'll be the cook who had an idea. They'll be the engineers who implemented it. Margaret picked up her bag. Sergeant, I don't need credit. I need engines to start. She walked toward the hangar exit, then paused. Tomorrow night, 2200 hours, I'll bring the components. Kowalski watched her leave, still holding the drawing, wondering if he'd just agreed to the smartest thing he'd done all war, or the stupidest. Outside, the temperature was dropping toward -45. And somewhere on the flight line, another engine was slowly freezing solid. February 5, 1943, maintenance hangar, 2200 hours. Margaret arrived with everything she'd requisitioned from base supply, officially listed as kitchen maintenance materials. 50 feet of half-inch copper tubing, compression fittings, insulation wrap, and a pressure gauge. Kowalski had already prepared the test engine, removing the cowling completely to expose the cylinder block and oil pan. They worked in silence, Margaret directing the layout while Kowalski made the connections. The tubing wrapped around the engine block in 3 loops, passing close to the cylinders where heat was most needed. A second run circled the oil pan, ensuring the lubricant would stay fluid. The inlet connected to a steam line Kowalski had tapped from the hangar's heating system. The outlet vented outside. Steam pressure, Margaret asked. 15 psi. Boilers rated for 40, but we're keeping it conservative. Temperature, 212 degrees at the source. Should drop to 190 by the time it reaches the engine. Margaret checked the connections, ensuring every joint was secure. The system was simple, almost primitive, but the physics were sound. Steam carried heat through convection, the copper conducted it efficiently, and the metal of the engine block would absorb and retain thermal energy. At 22:30 hours, Kowalski opened the steam valve. The tubing hissed softly as pressure built. Condensation formed immediately on the copper surface. Droplets running down toward collection points they'd installed. Within minutes, the engine block began to warm, not dramatically, but measurably. Kowalski placed his bare hand on the cylinder head. It's working, metals warming evenly. They monitored the temperature every 15 minutes. By midnight, the engine block had reached 45 degrees Fahrenheit, cold by any normal standard but tropical compared to the minus 43 degrees outside. The oil pan registered 38 degrees. Margaret checked the dipstick. The oil flowed freely, its viscosity normal. At 300 hours, they attempted a cold start. Kowalski disconnected the steam lines, removed the tubing, and restored the engine to standard configuration. Then he climbed into the cockpit and engaged the starter. The propeller turned smoothly. The engine caught on the second revolution, running rough for 5 seconds before settling into a steady idle. No grinding, no seizing, no fractured connecting rods. Kowalski let it run for 10 minutes, monitoring oil pressure and temperature. Everything was normal. He shut down the engine and returned to where Margaret stood beside the test equipment. "It worked," he said simply. Margaret allowed herself the smallest smile. "It's just thermodynamics. It's the first thing that's worked in 3 months. Kowalski looked at the steam equipment, then at the flight line where 20 other aircraft sat freezing. "We need to show this to Colonel Matthijs. Now. Right now, before another engine seizes." Colonel Matthijs's office, 3:45 hours. The colonel had been awake anyway. The operations tempo at Lad Field didn't allow for regular sleep schedules. He listened to Kowalski's report without interrupting, occasionally glancing at Margaret, who stood at attention despite being a civilian. When Kowalski finished, Matthijs leaned back in his chair. "You tested this on a single engine once for 6 hours." "Yes, sir." "And you want me to authorize installation across the entire flight line based on that?" "Sir, the system works. The engine started clean. No damage, no stress, no risk." "The risk is that we install untested equipment on operational aircraft and something fails catastrophically." Matthijs looked at Margaret. "Mrs. Hayes, you designed this." "I observed the principles, sir. Sergeant Kowalski implemented it." "You have engineering credentials?" "No, sir. Just 20 years watching my husband maintain aircraft." Matthijs stood, walking to the window that overlooked the dark flight line. "We're losing aircraft faster than we can repair them. The ferry route to the Soviet Union is critical. Those planes keep the Eastern Front supplied. If we can't maintain operational tempo, the entire strategic balance shifts." He turned back to face them. "But if I authorize this and something goes wrong, if steam pressure ruptures a line near fuel, if condensation causes electrical failures, if the system creates any safety hazard, then I've endangered every crew on this base." "Sir," Kowalski said carefully, "we're already endangering them. 15 engines destroyed in 2 weeks. How many more before we ground the fleet entirely?" Matthijs was silent. Margaret spoke quietly. "Colonel, I understand the risk, but the current procedures aren't working. This is a chance to change that." "You're a cook, Mrs. Hayes. Why should I trust your judgment on aircraft maintenance?" "Because I'm not asking you to trust my judgment. I'm asking you to trust physics." She met his eyes. "Steam carries heat. Engines need heat. The rest is just plumbing." Matthijs looked at Kowalski. "How fast can you install this system fleet-wide?" "If we use existing steam infrastructure and fabricate tubing on site, 72 hours for 20 aircraft. Maybe faster if we train additional crews." "Do it, but I want monitoring on every installation, temperature logs, pressure checks, inspection reports. First sign of a safety issue, we shut it down immediately." "Yes, sir." Matthijs looked at Margaret. "Mrs. Hayes, you've just redesigned cold weather aviation procedures for the United States Army Air Forces. That's not going to sit well with a lot of engineers who have been trying to solve this problem for months." "I'm not trying to make them look bad, sir. I'm trying to keep engines running." "I know, that's why I'm approving it." He walked back to his desk. "But understand this, if it works, the credit goes to the maintenance teams and engineering oversight. That's how the Army works." "I understand, sir." "Good, then get back to work, both of you." They saluted and left. Outside, the temperature had dropped to -48. But inside the maintenance hangar, steam was already flowing through copper tubing, keeping engines warm, keeping oil fluid, keeping the Alaska-Siberia ferry route alive. Margaret Hayes walked back toward the mess hall, knowing she'd just changed something fundamental. And knowing that by tomorrow, no one would remember she'd been the one to see it first. February 8, 1943, Ladd Army Airfield, Flight Line. The transformation happened in 72 hours. Maintenance crews worked around the clock, fabricating copper tubing assemblies in the machine shop, tapping into existing steam lines from the base heating system, installing the preheating equipment on every operational aircraft. The system was standardized: 3 loops around the engine block, 2 around the oil pan, inlet and outlet connections accessible from the ground, disconnect procedure taking less than 3 minutes. By February 8th, 18 aircraft were equipped. By February 10th, the entire operational fleet had the heating system installed. The results were immediate. C-47s that had required 4 hours of preparation and 2 failed start attempts were now ready to fly in 30 minutes. Engines started smoothly, oil pressure normal, no grinding or seizing. Ground crews no longer spent freezing hours nursing engines through thermal cycles. Pilots no longer sat in cockpits wondering if the starter would destroy their power plant. The engine failure rate dropped from 15 per week to 0. Colonel Matthijs stood on the flight line, watching a C-47 start its engines with textbook precision. The pilot ran through his checklist, both engines turning smoothly, exhaust clear, oil pressure climbing into the green. 2 weeks ago, this aircraft had been grounded with a seized engine. Now it was ready for the ferry route to Siberia. Staff Sergeant Kowalski approached, carrying a status report. "Sir, all 23 aircraft are operational. 0 cold start failures since implementation. Maintenance hours down 40%. We're not replacing damaged engines or running constant warming cycles. Fuel consumption down 32% for ground operations. No more extended engine runs to maintain temperature." Matthijs took the report. The numbers told a story that would matter to Pentagon logistics officers and appropriations committees. A simple modification using existing infrastructure had restored operational capacity while reducing costs. It was the kind of innovation that won wars without firing shots. "The Army Air Forces Technical Command wants a full report," Matthijs said. "They're sending a team to evaluate the system for implementation at other Arctic bases." "When, sir?" Next week, and they'll want to interview the development team. Matthijs paused. That's you, Kowalski, and your engineering staff. Sir, Mrs. Hayes designed the system. She should be. Mrs. Hayes is a civilian cook. The AAF doesn't give credit to civilian cooks for aircraft modifications. Matthijs's voice wasn't unkind, just factual. You'll be listed as primary developer. Your team will get the recognition. That's how this works. Kowalski said nothing. Make sure the system documentation is complete. Technical drawings, installation procedures, safety protocols. They'll want to publish it in the field modification manual. Yes, sir. Matthijs walked back toward operations, leaving Kowalski standing on the flight line beside the steam lines that fed into aircraft engines. The system that Margaret Hayes had envisioned while watching a teapot in a kitchen. The system that had saved the Alaska ferry route. The system that would now be credited to people who hadn't designed it. Base Mess Hall, 1200 hours. Margaret served lunch to pilots rotating through the flight schedule, the same work she'd done every day since arriving at Ladd Field. Nobody mentioned the engine preheating system. Nobody asked her about thermodynamics or copper tubing or steam pressure. She was the cook. She served food. That was her role. But she'd overheard the pilots talking, heard them discuss how the cold start problems had vanished, how engines were reliable again, how the ferry route was back on schedule. She'd heard the relief in their voices, the way they talked about trusting their aircraft again. That was enough. Staff Sergeant Kowalski found her during the afternoon lull, carrying a folder. He sat down at the corner table where she was cleaning serving trays. Mrs. Hayes got a minute. Of course, Sergeant. He opened the folder, showing her the official technical documentation for the preheating system. Detailed drawings, pressure specifications, installation procedures. Her rough sketch had been transformed into professional engineering diagrams, complete with Army Air Force's letterhead and approval stamps. This is going service-wide, Kowalski said. Every Arctic base, every cold weather operation. They're calling it the Kowalski preheat system. Margaret studied the documents. Her design, refined and formalized. Her observation about steam and heat transfer, translated into military technical language. Her solution to a problem that had been killing engines and endangering crews. With someone else's name on it. Congratulations, Sergeant. Ma'am, this isn't right. You designed it. You saw what nobody else saw. And you built it, you tested it, you convinced the colonel to implement it. Margaret closed the folder. The system works, that's what matters. You don't care about the recognition. I care that engines start. I care that crews come home. She met his eyes. My husband's name wasn't on any of the systems he developed either. He was just a mechanic. But the planes he maintained flew safely because he paid attention to details nobody else noticed. That was his legacy. Kowalski was quiet for a moment. The AAF team is coming next week. They'll interview me about development process, design rationale, testing procedures. I could tell them the truth about where the idea came from. And they'd write it off as a mechanic being generous to a widow who made a lucky observation. Margaret stood, picking up the serving trays. Sergeant, you've been in the Army long enough to know how this works. The institution takes credit because the institution needs credibility. Individual names don't matter. They should. Maybe, but they don't. She walked toward the kitchen, then paused. Just make sure the documentation is clear. Make sure every base knows how to install it correctly. Make sure maintenance crews understand the pressure limits and safety protocols. That's what matters. Kowalski watched her disappear into the kitchen, still holding the folder with his name on the cover page. Outside, another C-47 started its engine smoothly, oil flowing freely, metal warm enough to function in temperatures that would kill exposed skin in minutes. 600 miles away, A bomber crew preparing for the ferry route to Siberia completed their pre-flight checks without a single engine problem. And in a kitchen on an Alaskan airbase, a widow who changed aviation maintenance procedures returned to serving food, her contribution already fading into the institutional memory of people who would never know her name. March 1943, Nome Army Airfield, Alaska. The preheating system reached Nome in late February, installed by maintenance crews who'd been trained at Ladd Field. The installation took 2 days. The results were immediate. Lieutenant Commander Peterson stood beside his PBY Catalina flying boat, watching ground crew disconnect the steam lines after overnight preheating. The twin engines, temperamental in the best conditions, lethal in Arctic cold, started on the first attempt. Both propellers turned smoothly, oil pressure climbing normally, exhaust clean. Peterson had been flying the Alaska route for 8 months. He'd lost 2 engines to cold seizure, survived 1 emergency landing on sea ice, and watched 3 other crews go down when their power plants failed at altitude. The preheating system wasn't just a convenience. It was the difference between mission success and becoming a statistic. His navigator, Ensign Morrison, climbed aboard carrying the flight plan. "Sir, we're clear for departure. Weather's holding, visibility 5 miles, ceiling unlimited. Cargo status: medical supplies, radio equipment, 3 passengers bound for the Aleutians." Peterson completed his pre-flight checks, nodding with satisfaction that every gauge read normal. No oil pressure warnings, no temperature anomalies, no mechanical hesitation. Just 2 engines ready to fly. They lifted off at 8:30, climbing to 8,000 feet, heading southwest toward the Aleutian chain. The engines ran smoothly throughout the 4-hour flight, maintaining power, burning fuel efficiently, showing no signs of the thermal stress that had plagued Arctic operations. When they landed at Adak, the ground crew there had already installed the preheating system on their own aircraft. Word was spreading through the ferry route network, not through official channels, but through mechanics talking to mechanics, pilots sharing what worked. By April, every airfield from Fairbanks to the Bering Strait had the system installed. May 1943, Soviet territory, Yulkal Airfield. The system crossed international borders. Soviet maintenance crews, working alongside American advisors on the Lend-Lease ferry route, observed the preheating equipment and requested technical documentation. The Army Air Forces provided it, complete with installation procedures, pressure specifications, and safety protocols. Within weeks, Soviet bases in Siberia were fabricating their own copper tubing assemblies, tapping into their coal-fired heating systems, keeping American-made aircraft operational in temperatures that regularly dropped below -60. The modification that had started in an Alaskan kitchen was now keeping the Eastern Front supplied with bombers and fighters. Soviet pilots flying American P-39 Airacobras, and Havocs never knew that their engines started reliably, because a widow had watched steam rise from a teapot and understood heat transfer. They just knew the engines worked. July 1943, Ladd Army Airfield. The statistics accumulated over 5 months told an unmistakable story. Engine failures due to cold starts, reduced from 63 in January-February to 4 in March-July. 3 of the 4 failures were attributed to improper installation or maintenance errors, not system design flaws. Operational aircraft availability increased from 62% to 94%. Aircraft delivered via Alaska-Siberia ferry route, 2,847 planes in 5 months, compared to 1,923 in the previous 5-month period, a 48% increase. Maintenance hours per aircraft, reduced by 37%. Ground operation fuel consumption, reduced by 41%. Lives saved, Impossible to quantify directly, but every pilot who didn't crash due to engine failure, every crew that completed their mission because their power plant remained operational, they were alive because engines started reliably in Arctic conditions. Colonel Matthijs compiled the data into a report for Army Air Forces Command. The report credited innovative field maintenance procedures developed at Ladd Field with restoring operational effectiveness. Staff Sergeant Kowalski was commended for exceptional technical leadership in cold weather aviation operations. Margaret Hayes was not mentioned. The report was classified, filed, and used as the basis for implementing the preheating system at Arctic bases worldwide. By the end of 1943, it was standard equipment from Alaska to Greenland to northern Canada, anywhere aircraft operated in extreme cold. The system worked, the mission succeeded, the war effort benefited. And the woman who'd made it possible continued serving food in a mess hall, her contribution invisible to everyone except the few who'd been there, when she'd first suggested that steam could keep engines alive. September 1943, Army Air Forces Technical Command, Wright Field, Ohio. The formal evaluation report arrived at Wright Field with classified markings and priority routing. Engineering officers reviewed the Alaska preheating system with professional interest. It represented exactly the kind of field innovation the AAF wanted to encourage and document. Captain Richard Holloway, Chief of Cold Weather Aviation Research, read through the technical specifications with growing approval. The system was elegant in its simplicity. Existing infrastructure, minimal cost, immediate implementation, measurable results. Everything the military valued in an innovation. Who developed this? He asked his assistant. Staff Sergeant Kowalski, maintenance supervisor at Ladd Field. Former civilian mechanic, career Army, 26 years experience. Holloway made notes. Schedule him for an interview. I want to understand the development process, the testing methodology, how they identified the solution. Yes, sir. 2 weeks later, Kowalski sat in Wright Field's engineering office, answering questions about preheating system development. He explained the physics, the installation procedures, the safety protocols. He was thorough, precise, professional. Holloway listened carefully. Sergeant, this level of thermodynamic understanding is unusual for field maintenance personnel. Where did you learn heat transfer principles? Kowalski hesitated. 26 years working on engines, sir. You learn what works. But the specific application, using steam circulation for active heating rather than passive insulation, that's a conceptual leap. How did you arrive at that solution? Another pause. Observation, sir, watching how different heating methods performed in Arctic conditions. It wasn't technically a lie, but it wasn't the truth either. Holloway accepted the explanation because it fit the narrative he needed. Experienced NCO uses practical knowledge to solve operational problem. That story would work in official reports, in training materials, in the documentation that would spread the innovation across the service. The real story, Widow observes kitchen equipment and makes intuitive connection, wouldn't work. It would raise questions about proper development channels, about why civilian personnel were designing aircraft modifications, about command authority and institutional credibility. So the real story was quietly edited out. The official AAF History of Cold Weather Aviation Innovations, published in 1944, included 3 paragraphs about the Kowalski preheat system. It credited field maintenance innovation under extreme operational conditions and recommended Sergeant Kowalski for commendation. Margaret Hayes did not appear in the text. December 1943, Ladd Army Airfield. The commendation ceremony was brief. Colonel Matthijs presented Staff Sergeant Kowalski with the Soldier's Medal for technical achievement, resulting in significant improvement to operational capability. The entire maintenance section attended, along with flight crews who'd benefited from the preheating system. Margaret Hayes watched from the back of the assembly hall, standing with other civilian base personnel. She'd been invited because she worked on base, not because anyone remembered her contribution. Kowalski gave a short speech, thanking his maintenance team, acknowledging Colonel Mathias's leadership, praising the ground crews who'd implemented the system across the flight line. He didn't mention Margaret. The omission wasn't cruelty, it was institutional necessity. Crediting a civilian cook would undermine the credibility of the innovation. After the ceremony, Kowalski found Margaret in the mess hall. "Ma'am, I'm sorry." "For what, Sergeant?" "For not telling them the truth about who really designed the system." Margaret poured him coffee. "You told them the truth that matters. The system works. It saves lives. That's the truth that needed telling." "But your name should be in the record." "My name is in the record, just not the official one." She gestured at the pilots eating lunch nearby. "They're flying missions that would have been impossible 6 months ago. Engines start reliably. Crews come home. That's my record." Kowalski sipped the coffee, saying nothing. "Sergeant, my husband spent 20 years maintaining aircraft. He developed procedures, made improvements, solved problems that saved lives. None of it was officially credited to him. He was just a mechanic." Margaret refilled her own cup. "But he told me once that the real measure of good work isn't recognition. It's whether people who depend on your work come home safely." "He sounds like he was a good man." "He was, and he taught me that engineering is just applied observation. You see a problem, you understand the physics, you apply a solution. The rest is just paperwork." Kowalski finished his coffee and stood. "Mrs. Hayes, for what it's worth, I'll make sure the maintenance training manual includes the full development story. Maybe someday someone will read it and understand where the idea really came from. Maybe, or maybe they'll just use the system and never wonder about origins." Margaret smiled slightly. "Either way, engines will start." Kowalski returned to the maintenance hangar, where a new batch of aircraft awaited preheating installation. And Margaret returned to serving food, her innovation now standard procedure across the Arctic, her name absent from every official document that described how it worked. 1946, Seattle, Washington. Margaret Hayes left Alaska in March 1946, 2 months after the war ended. Ladd Army Airfield was scaling down operations, civilian contractors were being let go, and there was no reason to stay in a place that had served its purpose. She returned to Seattle, found work at a hospital cafeteria, and settled into a life that looked nothing like the 2 years she'd spent on an Alaskan airbase. Nobody at the hospital knew about the preheating system. Nobody asked about her war work. She was just another middle-aged widow, finding her way in a post-war economy. Occasionally, she'd read news articles about aviation advances, jet engines, pressurized cabins, improved navigation systems. The articles never mentioned cold weather operations, never referenced preheating systems, never acknowledged that keeping engines warm had been as important as making them powerful. The innovation had been absorbed into standard practice. It existed in maintenance manuals, in training curricula, in procedures that mechanics followed without questioning why. It was invisible because it worked, and things that work become assumptions. In 1952, a former Ladd field pilot recognized her in a grocery store. He'd flown the ferry route in 1943, remembered the transformation when engines started reliably, wanted to thank whoever had solved the problem. Margaret listened politely, accepted his thanks, and never mentioned that she'd been the one who'd first seen the solution. What was the point? The system worked, that was enough. 1967, Aviation Maintenance Training Center, Chanute Air Force Base, Illinois. Technical Sergeant Davis taught cold weather maintenance procedures to new Air Force mechanics. The curriculum included a section on engine preheating, complete with technical diagrams and installation procedures. This system was developed during World War II for Arctic operations, Davis explained to his class. It uses steam circulation to maintain engine temperature overnight, preventing oil from thickening and reducing cold start failures. A student raised his hand. Who invented it, Sergeant? Davis checked his instructor's manual. Developed by maintenance personnel at Ladd Army Airfield in Alaska, 1943, credited to Staff Sergeant Kowalski and his team. Any of them still around? Kowalski retired in 1954, died in '61. Davis moved to the next slide. What matters is understanding the principle. Active heating maintains temperature more effectively than passive insulation. The lecture continued. The students learned the procedures, memorized the pressure specifications, practiced the installation techniques. None of them learned about a widow who'd watched a teapot and understood heat transfer. The knowledge survived, the story didn't. 1982, Anchorage, Alaska. Margaret Hayes died at age 82 in a nursing home outside Anchorage. She'd moved back to Alaska in the 1970s, drawn by memories of the 2 years when her work had mattered most. The obituary in the Anchorage Daily News mentioned her service as a civilian contractor during World War II, her work in hospital kitchens afterward, her quiet life. It did not mention the preheating system. It did not mention that her observation had saved hundreds of lives and changed Arctic aviation procedures. It did not mention that modern aircraft still used variations of the principle she discovered. 14 people attended her funeral, neighbors, a niece from Seattle, a few acquaintances from church. No military honor guard, no Air Force representatives, no aviation historians. She was buried in a civilian cemetery with a simple marker. Margaret Hayes, 1901-982, beloved wife of Robert Hayes. 1998, Air Force Historical Research Agency, Maxwell AFB, Alabama. Dr. Catherine Werner was researching World War II aviation logistics when she found an anomaly in the Ladd Army Airfield maintenance records. The documents showed a dramatic improvement in cold start engine reliability beginning in February 1943, coinciding with implementation of a preheating system. The official record credited Staff Sergeant Kowalski, but Werner found handwritten notes in the archived files, rough sketches and observations about steam heat transfer, dated 3 days before the first official test. The handwriting wasn't Kowalski's. The signature at the bottom read M. Hayes. Werner cross-referenced the name with base personnel records. Margaret Hayes, civilian contractor, mess hall cook, employed January 1942 through March 1946. No technical credentials, no engineering background. Werner spent 6 months reconstructing the timeline. The kitchen observation, the initial test, the fleet-wide implementation. She documented how a widow's understanding of thermodynamics had solved a problem that was crippling Arctic aviation operations. She published her findings in the Journal of Military History in 2000. The article was thorough, well-documented, and cited by subsequent researchers studying WWII technical innovations. It reached an audience of approximately 300 specialists. 2010, National Museum of the United States Air Force, Dayton, Ohio. The Cold War Aviation exhibit included a section on Arctic operations, featuring a restored C-47 transport that had flown the Alaska-Siberia ferry route. A small display described the challenges of cold weather flight and the solutions developed during World War II. One paragraph mentioned the preheating system. Maintenance crews at Ladd Army Airfield developed steam circulation heating to prevent engine failures in extreme cold. This innovation, initially credited to maintenance supervisor S.SGT Kowalski, enabled reliable aircraft operations in temperatures below -50 degrees F. A footnote added after Dr. Werner's research was published. Read. Recent historical analysis suggests the initial concept was proposed by Margaret Hayes, civilian contractor, based on observation of industrial steam equipment. Most visitors never read the footnote. Present day. The principle Margaret Hayes discovered with a teapot is now standard practice in aviation. Modern aircraft use electrical heating systems, but the concept remains identical. Maintain engine temperature to ensure reliable starts in cold conditions. Mechanics worldwide follow preheating procedures without knowing the origin story. Pilots fly Arctic routes without understanding that their engines start reliably because someone once noticed that steam carries heat efficiently. The innovation survived because it worked. The innovator disappeared because that's what happens when practical observation challenges institutional expertise. Margaret Hayes never became famous. Her name appears in one academic journal article, one museum footnote, and the archived maintenance records of an Alaskan air base that closed decades ago. She received no medals, no monuments, no popular recognition. But every aircraft that starts reliably in extreme cold operates according to principles she identified. Every mechanic who uses preheating procedures builds on the foundation she established. Every pilot who trusts their engines in Arctic conditions benefits from her observation about teapots and heat transfer. She saw a problem that was killing people. She solved it using knowledge from a completely different context. She proved it worked, watched it spread, and then disappeared into the anonymity of civilian life. That's not tragedy, that's not injustice. That's just how most innovation actually happens, quietly, practically, by people who care more about solutions than recognition, who understand that the measure of good work isn't credit but whether people come home safely. Somewhere in Alaska, there's a cemetery with a simple marker. No mention of aviation history, no reference to Arctic operations, nothing that would tell a visitor why the name matters. But in maintenance manuals and training curricula and standard operating procedures, the principle remains. The teapot trick outlived its inventor by decades. And somewhere in conditions cold enough to kill, an aircraft engine starts smoothly because steam carries heat and someone once paid attention. That's the only legacy that matters.